Hello viewers, welcome back to this course. So today we are going to do the lecture number 4, and in the previous 3 lectures we have discussed some basics about the Matlab, and in this lecture also we are going to do some basics. So in this I will explain that how we can define a function in a Matlab, and then we can use this function later on to in your script files to do other codes. So let's go to the Matlab windows. So this is my Matlab window, and so there is no variable there in the workspace. So today we will discuss that. So today I will define you the command that is VPA. So this is another command that is the. So this command gives you that variable precision arithmetic. So what it saves, because like suppose I want to define what is pi. So pi gives you the value 3.161416, or if I write format long and then if I define the pi, so it gives you the 16 digit value. And if you see this one whose, so it shows you that it is a 8 byte and double. So it means that it is giving you the everything whatever we are doing in the Matlab, it is giving you the double precision. The number is given to you in the double precision, means correct up to 16 digits. But suppose I want to increase the precision, so I will write down the command that VPA. So VPA command gives you that I will define then that pi, and suppose I want to define this with the 20 digits accuracy. So I will write this one. So this is the value of the pi, and it is coming with the 20 digits. Or maybe I want to, suppose I want to increase the accuracy digits, so I want 40 digits. So that gives you the value of the pi up to 40 digits. Similarly, I can define the value of, maybe I want to define square root of 2 with 30 digit accuracy. So that is the value of the square root 1.41, and then this is the accurate up to the 30 digits accuracy. So this type of command VPA is used when we want to define or we want to use the values of any fractions or a function like pi or under root pi, square root pi, and for a large number of accuracy, or maybe a accuracy up to 40 digit or 30 digits. So we use this VPA command. Now we start with the functions. So in this case we will define the anonymous function. So let's do the functions, how to define the functions. So in anonymous functions. So anonymous function means, suppose I have a function like this one. My function, I define a function fx is equal to, suppose I want to calculate x cube plus maybe x square minus x plus 2. So this function I want to use in my Matlab program. So how to define these functions in a Matlab command window or in a later on in the script file. So let's define this one. So this is that how we will define. So that is the definition, this function is defined. So it gives you the definition. So first is the function name. So this is the name. So that is equal to, and I will use the word at the rate, and then I will find out the list of variables, and then the function. So I will write the function name, and then I will put the sign at the rate, and then the list of variable, and then I will define the function. So for example, I define the function whatever I just defined. I will write f is equal to at the rate, And now suppose this function is a one dimension, just a function in a 1D. So I will define a function of only one variable, and then I will define x raised to power 3 plus x raised to power 2 minus x plus 2. So that is my function. Now you can see that it is coming in the workspace, and its value is f is a function with a function handle. So function handle means it will give you the name of the function. Now suppose I want to find the value of the function f1. So f1, if I put there, it gives you the value of 3, or maybe f0 I want to find, this gives the value of 0. Maybe I can define what is the value of the function f at maybe a large value 50. So that gives me the value of the function at f50. Suppose I want to calculate the value of the function for not for at one value, but suppose I take a vector of values. So I define 0, 1 and then 10 and then 100. So this is the one vector I define. So that is my vector, and now I want to find the value of f at x. So now it gives you the error, and error using the sign this. It means that in this case we have defined the function, that function is a scalar, but the value I am giving is a vector form because it is a one dimensional vector. So in this case what I will do, I will redefine the function so that this function can be compatible with the vector values also. So in this case I will define this one f the same way, but only I will put the dot sign as we have done in the case of defining the vectors. So now this is my function, and now everything will be same, the value of the function will be same, but now I can pass the value of x here. So now I will define the value, and this is the value of the function. So my value of x was 0, 1, 10 and 100, and that is the value of the function at 2, 3, 1092 and this is. So this is the value of the function given at various values of this one. Then I can plot the value of the function x and then fx. So that is the, I can plot the function that this is the value of the function. So in this case I can define the value like I define a function x is equal to, maybe I define linspace, and then from 0 to maybe I will take 10. So this is the function I am defining. Then I define fx, and then I define the plot. So plot x fx. So that is the value of the. So in this case what it is giving you, that this is the x I am taking from 0 to 10, and this is linspace I am using. So it is giving you the default 100 values of the function of x from 0 to 10, and based on this one I will find the value of fx, and this is the plot I am doing. So that is the plot of the function, this one, for the x range from 0 to 10. So this is the way we can define the function. So this function is a, we have defined in one dimensional. The same way I can define the function. So let's find out the another function. So let's say take ff, the another function I define. So this function I define at the rate, maybe I can define for two variable now, x and y, and this is I defining x square plus, so dot y square minus x dot star y. So that is another function I am defining. Now I can define the function that is compatible for both scalar and vector. So that's why I put the dot here. So this is a two dimensional function I have. Now I can calculate the value of 1 and 2 for this function, putting the value of the function here. So that gives the value 1. Or maybe I can define the function, this x I can put 1 and y I can put, so just it gives the value 1. So y I will put as a. So that gives you the value, that undefined function on a variable a. So in this case what I can do, I can take the value of x and here I can put maybe y only. So this is f x. So that is the, okay, so I have not defined the value of the function y. So y maybe I can define y is equal to, I can define linspace, or maybe I can define clear x. So this, we have cleared the x. Now I can define that x is equal to maybe another vector. I am defining 1, 2, 3, 4. So this is the vector I am defining, and similarly I defining the values maybe 0, 2, 5, 8. So that is another value I have defined, y. Now I can pass this one x and y. So that is the value. So now this value gives you for this value of x and this value of y. Similarly I can define that, suppose I define it for 2, so that gives the value. In this case my x is 2 fixed and this y I can find. So in this way I can define the function value, the function for various this one. Maybe I can define a, now I define x is equal to a linspace from -2 to 2. Suppose I define this one, and then my x is equal to x. So I just make the row vector the column vector. Then I define a function various values. So various value I can define as, so I define the value of the function for x, y 0, then maybe x at 1, x at 5, or not 5, y is equal to 5 maybe, okay, and then ff x and 10. So let us take only this value. So this is the value of the function. So I have taken, now I have calculated the value of the function for x, whatever the x I have just defined the linspace, CLC I can do. So this is the value of the function I have defined, and this is the x I have defined, this is my x, and then I define the value of the function. Now I can plot all values together. So in this case I will do x and then various value. So this one various value I can define. So using plot, because my x is, so my, I just want to check the size of this one. So this is the size. Now various value, this is one row and the columns, and this is one row 100 columns. Now what I do is x is equal to x dash. Now I can define. Various values also, just and now maybe, so this one is the value of the hem, because earlier actually it was showing you that only this was the column vector and that was the row vector, but now it is x is the column vector, and with respect to x I am plotting all the functions, which the first column is the first function, the second column is the second function. So all the 4 values functions I can plot in just a single way. So that is the plot x various values of x. Maybe I can find the put grid there. So this will give you the grid, and then in the I can find the x labels. So x label is that axis, and similarly I can define the y axis. So that is, this gives you the y-axis, and that is the plot. Or maybe I can put the legends. So in the legend, so that is the way we can define the legend. So legend give the what are the value of the function. So legend is string 1, string 2, string 3, and this is gives you that which function is dependent by what. So I can define, so this is the command I can, and then I can define the legend, first, second, third. So that gives the legend. So this is the first, this is the second. So this is the first function, second function, third function, and I give you that the location, it is the northeast outside. So that is the northeast outside. So this is the northeast, and we put this one on the outside. So similarly this one I can define anywhere, wherever you want to like. So this way we can define the function. Now maybe I can define another function. So I just close this one and I do the CLC, and I will clear all the variables. Now maybe I can define another function that I just g is equal to at the rate, or I can define the polynomials. So capital P is equal to at the rate some a and x, where a is the some parameter I am defining, and then I define polynomial a4 into x power maybe 3 I can define, plus a3 multiply by x dot square plus a2, and then multiply by x dot, so this is just the x I am defining, and then plus a1. So this is the polynomial I have defined, where I have defined that a is the parameter, and this is the coefficient I am defining, a4, a3, a2. So this is a general cubic polynomial. Now I define what is my a. So a I just defined here, that a is, suppose I give a is 1, then 2, then 4, then 6, and I want to this one. So this is my a. Now I want to define what is my p. So that is the value. So I will just define that, gives the value of this x here. So suppose I give the value maybe 1 here, so that gives the value 13. So in this case my a will be, so this a1 will be a1. So this is the vector I have given, because here I have to give the value of the vector a, which has the 4 component, a4, a3, a2 and a1. So this is the a1, a2, a3 and a4. So that gives you the value of the function here. Or maybe I can define what is my p for a, 0. So you put the value of 0, it gives the a1 only. So that is my a1. So in this case we can define this function polynomial in this way, or maybe I can define some other values, or I can define if x is equal to 0, 1, 2. So this is a vector I am defining, and now I can pass the value of to this capital P, a and x. So that gives you the value of the polynomial for value of a, and then this x is the vector. So it gives you the value of the polynomial at 0, 1 and 2. So the 3 values together we can find out. Then I can maybe plot this function. So for plotting maybe I need more value of x. So, I will define the x is equal to linspace, and I will put the value from 0 to maybe 10. So, this is the value I am defining, linspace, and then I will define plot. So, in this case I will define x and then p for a x. So, that is the plot. So, this is the polynomial we have just defined. So, it gives you the value of the polynomial from 0 to 10 for those value of coefficient. So, my a coefficient are the same, or maybe I can change the coefficient now, and I just put the coefficient -1, then 2, then -3, then 4. So, let us take this point. So, in this case my polynomial will change, and this is the polynomial now we are getting. So, this is the value of a, and so let us see what is the value of capital P at a 1, 2, or maybe I will put 0, then it is -1. So, this is the plot we are getting from here, that is the polynomial we have. So, this polynomial in this case is starting from 0 and going up to this, the value 3500, maybe more than that. That I can define from, so P at A10 is, so that is the value, it is going up to 3719. So, this is the way we can define the plot. Now, the same way the function we have defined, that it is anonymous function we have defined, the same way I can define the function that is called inline functions. So, what is the inline function? So, the same way I want to define the function. So, in this case I will just give the help inline. So, this gives the inline construct inline objects. So, inline function means you are doing some calculation or you are writing some code, and in between you want to define a function. So, that is called the inline function. So, this is the expression of the function, or maybe I can define that G is the handler, the name of the function, and then I can define inline t square or inline this function we have defined. So, similarly I can define the same function. So, let us define another function. So, before that I just clear all. Now, CLC. So, in this case I just want to define capital F is equal to, let us define inline, and then so that is the way I can define, and here I will give the function formula, and that is the way we can define the function. So, before that I just put the percentage sign. So, that is the command. Now, so suppose I define f is equal to inline, maybe I defined the x square into multiplied by sin x. So, this is the function I just defined. So, that is my capital F. Now, I can find what is the value of capital F at 0, or what is the value of the capital F at 1. So, all the values we can put the same way we have defined the anonymous function, the same way we have defined the inline function, or maybe I can define the, because now suppose I want to give the value of the function, I just define x is equal to maybe 0 and 1. So, this is the vector I have defined, and now I want to give this value. So, it will not accept the value because this function is a scalar function. So, the same way I have to redefine the function by the vector form. So, putting here dot before the exponential sign and the multiplication sign.
Now I can define my function, and that gives you the value of the function at x equal to 0 and x equal to 2. So, in this case maybe I can define this function for 0 maybe pi by 4, pi by 2, pi by maybe I can define 3, pi by 4 and less in the last pi. So, this is the function the value of the x I am defining, and then I can define the value. So, that is the value of the function here. Now, maybe I can define what will be the sign of the function capital F at pi by 2. So, this one I can use. So, first it will give you the value of the f. So, this is pi by 2, and then I have defined the sign of this one, or maybe. So, this is the way we can define another function or another value I can define. Maybe I can find the value of f, some value at pi by 3, and then I can take the square of this one. So, that gives you the value of the square root of this one. Or maybe I can define the zeros. So, I can define the zeros of the functions. So, this one will do in the so zero the function and other commands will continue in the next lecture. So, in this lecture we just talked about the anonymous function and the inline function, and then how we can use this function in between to find out to do the more computation using these functions. So, in the next lecture we will continue with these basics of the Matlab. So, thanks very much for viewing this.